Alright, here we are. Scope is all put back together, and it's been I've gone through it with the manual and done the alignments. Everything's aligned. I didn't have no issues with the alignments. Everything was able to come in like it was supposed to. And so right now I've just got it hooked up to the signal generator, looking at a 1 megahertz sine wave on the scope. We'll take a look at there's one more thing we can look at from the scope. We'll look at these filter cans. These are the filter capacitors that came out of the Eico originally, and one of these, this one in particular, has a definite hard fault. So we'll look at that on the we'll just look at it on the multimeter is the easiest way to look at it. It shows you, it'll show everything we need. And this one here has a section that's definitely suspect, but if you'll remember, I think I mentioned this, but the problem this scope had from the get-go was it was blowing the fuse, the power fuse, when you turn the scope on. That was the condition that I purchased it in. The previous owner said that it blows the power fuse when you turn it on, which that right there is a sign that there's definitely something wrong in the power supply section. So we'll take a look at that next. All right, and so we're back looking at these filter cans. These are the two multi-section filter cans that came out of the Eico, the oscilloscope. We'll just look at them here on the multimeter. I've got it set up for resistance, and we'll take a look at the cans. This one in particular, this is the main power supply filter can. It's a 3-section. There's two 40 microfarad sections and one 300 microfarad section. And this one has got an insulator around it. It was isolated from the this can, the common on this can was isolated from the chassis to allow it to be at a different potential, to allow this capacitor common to be at a different potential than the chassis ground, so that the circuit could develop a negative 40 volts to supply some biasing in the oscilloscope circuit. But we'll take a look at a couple of the sections here. So the can would be the common. So we'll just any one of these 4 outer tabs. And I don't know if this one. So this one, you can see the resistance. We started at 18K, and it's climbing. When you look at these just through an ohmmeter, a DC on a capacitor, you'll see this similar. You'll start off with a resistance value, and it should increase up to some value, and it'll stabilize out. It should not start at that low. So that section there is definitely suspect, and then you can see is it's basically charged at this point. So this section here is our fault. So you can see on the meter there we're reading 0.09 ohms. So that is definitely a hard short to ground, and that will definitely blow your power supply fuse when you turn this thing on. The third section here is the third section here seems to be okay, but definitely this section would be suspect, and we'll just discharge it here. Of course, this is low voltage, so we can do that. But there you go. So it starts at a low value of resistance, and it's going to come up. Again, this one being shorted. So out of this 3-section can, one section is definitely shorted. Another section is probably shorted. If it's not shorted, it's just about ready to go. And then one section seems to be okay, but but these cans, one section goes, you gotta change the whole one, and you're better off these days if you're gonna work with this type of equipment, this old tube equipment. That's just one thing you need to know, that these old cans, they're gonna have to go and get replaced with something modern. This is the other can. This was not in the main power supply section. This is a 3-section can cap, and each of the sections in here is 20 microfarads. So these sections were used in the horizontal section of the oscilloscope for some downstream filtering on the lower voltage portions of the circuit. And so this one, the can on this capacitor is isolated from the sections. So this capacitor has a center. It's a 3-section capacitor, but it's 4 terminals. So this terminal here is our common terminal. So we'll look at that now. So there you go. Starting at a lot lower now. 200, 300 megs, or 200, 300, not megs, kilo ohms, excuse me. Anyway, so just the same thing. Again, looking at these old cans, these things get, there you go. So that one started at 50K, and it's climbing up now. 400K, it's climbing up. That one started at 20K, it's climbing up slowly. Again, these things, they're old, they get dried out. They dry out, they start, the plates or the sections start shorting together, shorting to ground. You could do more extensive testing on these. I could put it on the ESR meter, but I'm not going to do that. Really, this stuff, these can caps and this, there's really no need to do that. You can pretty much see what you need to see with an ohm meter for this kind of stuff, as far as checking for shorts. And the first thing you do when you're going to start working on this type of equipment is you're going to change out, especially these power supply, these can caps. Get something that's a high temperature rated, a good quality capacitor. I like to use Nishikon, Panasonic. Those are the ones that I like to use. And don't buy them on eBay. Buy them from a reputable dealer. Buy them from DigiKey. Buy it from Mauser. Somebody that's reputable. You know what you're going to get, because there's so much fake, so many counterfeit components out there on the eBay market. You just really got to be careful with what you're buying. So that's it for this video. Like I said, I've got parts on order for the next phase of this project. It's going to be putting together the curve tracer portion. Will be when I get the parts, when I get the enclosure, we'll take a look at that, kind of go through some of the thoughts I have for laying out the curve tracer portion. We'll go through how I plan to interface it with the scope, and once I get some circuit boards. I'm not going to go through laying out the circuit boards, but once I get the circuit boards laid out and populated, we'll go through putting the components together in the enclosure, talk about some of the things I have in mind, maybe some things that look out for if you want to put together a project, some of the things I kind of look at when I'm putting together a project. And we'll get it put together, and we'll set it up, and we'll get it going. like I said, this project's based on a Patreon channel. Uh, the channel is Mr. Carlson's Lab. If you want to check him out, he's He's got a lot of good information on there. I'm not gonna share with you the specifics of his design because it's not public domain. But anything I design on my own, we'll take a look at that and kind of talk about what I thought, what I had in mind when I put the stuff together. And so that'll be the next part of this series. So I hope you enjoy what you see, and if you got any comments or questions, feel free to put those in the comment section. But that's all for now. Thanks.